minutes before it's officially going to start. So let me just see whether I can share my screen already. And I will start in 2 minutes. So if you need to get a quick coffee or something, that's still possible. Okay. Can you see my screen okay?
Yes, yes. Yes.
Excellent. Okay, so I think that we can start now. So welcome to the invited panel called No Logic is an Island, and it's about internal and external integration of logic programming paradigms. So let me start by very quickly explaining to you what we mean by this. So we want to talk about integration. On the one hand, internal integration. By this we mean integrating different logic programming paradigms and approaches with each other. So integration internally in the domain of logic programming, but also external integration, that is integrating key ideas from logic programming with other paradigms and other approaches, functional programming, imperative programming, etc. And we want to look at both practical issues, how to build systems, for instance, and more theoretic issues such as semantics, etc. And the kind of questions that we want to address is this desirable, the integration? Why is it desirable? Why not? In case it's desirable, how best to go about it or how not to go about it? What are various advantages, disadvantages? What did the past look like of integration efforts? And what do we think that the future might look like? And we're very lucky to have a panel of some very eminent scientists who have all done work on different aspects of this integration issue. You see their names on the slides here. And so what we will do in this panel discussion is I'm going to start by asking each of the panelists to give a short position statement of about 4 minutes. After we've had these position statements, I will give the panelists the opportunity to briefly react to the position statements of the other panelists in case they heard something that they want to comment on. And then we'll also give the audience a chance to contribute with some questions and comments about which the panelists can then say something. So I would like to start by giving the word to the panelists in the order that you see them here on the slide to give their position statements. So I will just present the slides of each of the panelists. And then if you see your slides pop up, you can just start talking. So I hope that Mark's slides here are first. So please go ahead, Mark, and tell me when I need to move to the next slide.
Okay, Joost. So I want to thank the organizing committee for inviting me to this panel. I will probably defend here the theoretical point of view. First slide. Can you show me the next slide? Okay, so something perhaps not sufficiently stressed in my opinion is the issue of the declarative side versus the procedural side of affairs. Logic programming, of course, started with this idea that the logic programming language is 2 languages in one, a declarative one, a procedural one. I think it was a very interesting idea worth to be explored. It's my own view that it didn't produce the anticipated added value for programming nor for knowledge representation. And so I think it might not be the right idea. The impact for this panel is that I want to focus on declarative logic programming paradigms. And for me, my own perspective, tools like answer set programming, Datalog, FOID are declarative knowledge representation, while Prolog and perhaps constraint logic programming are more take more the programming view. So I talk about the declarative logic programming paradigms and integration there. Next slide. Okay, so focusing on integration of declarative logic programming paradigms, I think one principle stands out, and that is, before we can even think about integration, we should start from a clear view of the declarative nature of logic programming. So what do logic programs mean? I think there is still this thorn in our side. The state of the art is still quite confused. There's no agreement about what logic programs mean. For some, it's a subset of classical logic. For some, it's a logical inductive definitions, maybe a default logic, not epistemic logic, logic of here and there. There is no disagreement. There are, of course, people with very strong opinions. For example, I am one of those. In my point of view, the right declarative view, the most fruitful point of view, the one that explains best the way logic programs are used, is that logic programming is a logic of inductive definitions. I think that explains best the applications of pure Prolog, also of Datalog, where queries are symbolic definitions of sets of interest. FOID, which is the logic of our IDLP system, and then also of ASP, although I believe many people will disagree with me. But for example, in the this year's autumn school of logic and constraint logic programming, I think Mirek Trushinsky defended this view even on ASP. Now, seen from the declarative point of view, seeing logic programming as a declarative logic of inductive definition, there is definitely need to extend and to integrate that logic with other declarative logic paradigms if you want to use it for knowledge representation. And that, I think, needs to be done in two steps. First of all, we need to open up logic programming and relax some of its closed world aspects too, which is the domain closure axiom, the unique names axioms, and to allow undefined predicates. And then we again need to extend the logic to represent non-definitional forms of knowledge. And for that, we need to introduce or integrate it with language constructs from first-order logic, aggregates, types, partial functions, epistemic operators, and so on. Okay, so that's my view on the integration issue. I want to say also something about the programming issue. That's the next slide. So I somehow dismiss the logic programming as a programming language view. On the other hand, I cannot entirely ignore the fact that, in my view, the logic programs are definitions, inductive definitions, recursive definitions. That is a kind of a constructive knowledge, and I have to admit that such constructive knowledge is a natural go-between between declarative knowledge and procedural knowledge. And in fact, I think that two declarative programming paradigms are built on this type of declarative knowledge, both logic and functional programming. But still, my problem there is that neither of these two paradigms have proven really suitable for knowledge representation. So that is my problem with this. My preferred view on the integration of declarative and procedural language is a more classical one. I think we need programming environments where declarative knowledge is stored in declarative knowledge bases, and the programming languages should be equipped with a rich interface to that knowledge base so that we can call the knowledge base for various forms of inference, not only querying, but also satisfiability checking, model generation, and so on, and other tools for interaction. And I think that is the evolution that is currently going on. It was certainly something we tried for our own knowledge-based system IDP, but I think this evolution is also quite visible in ASP systems, but also in mini-zinc systems and in Z3 SMT systems. Okay, thank you for the attention.
All right, so just, is there any way I can show the slides myself? Because the ones I sent you have no pauses, and they were meant with pauses. Do you mind if I send them myself?
Okay, I will, yes.
That's easy, I'll just do a quick. Wait. All right, so share screen. There we go. I'll stay in length. All right. So, well, first, thanks very much for inviting me for the panel. It's a fun and interesting topic, and definitely quite timely. I will present, as I imagine, Jan and Terry will also do, perspectives a little bit more from the modern Prolog systems perspective, and which I have to confess from the beginning with some abashed emphasis on our child Prolog system. So I apologize ahead of time for that. So the first question we were asked was about the convenience or the idea of combining different subareas or subformalism of LP. It's the first thing that just asked us. And of course, my answer is a definite yes. And many advances have been incorporated over the years to improve Prolog's reasoning capabilities. And this has often been combined done by combining with or interfacing with or taking ideas from other areas of LP. You know, the following is a little bit specific, perhaps to Chow Prolog, but I think it applies also to many other Prolog systems. Now, the first objective has been, I think, or is to regain pure LP, to regain purity. So for this, we have reconstructed the Prolog language from a pure subset. So starting for pure Prolog, all the built-ins, you know, should be put in libraries. At least that's what we did. And that way, if you combine it with the idea of modular extensibility, that you have a language that is extensible on a modular basis, or even on a part of a module basis, by you know, adding syntactic and semantic extensions at this level, then this allows having pure predicates and pure modules and combining them within pure code and so on, and navigating the space between classical Prolog and purity. Another aspect that is very important is enhanced termination and enhanced reasoning capabilities. So things that we have been added are additional control rules, breadth first, iterative deepening, random search rule, Andorra search rule, and of course tabling is a, you know, a major advance for termination and for enhancing reasoning. Of course, constraints, this affects more at the unification level, or the generalization of the unification level. And then another important aspect has been the improvement of negation, or the combination of with ASP. And this has a historical passage that I would call first constructing negation, and then interfaces to ASP systems. So the Prolog system talks to the ASP system, and now we also have top-down ASP. SCAS, you know, we had a whole workshop on that in ICLP, which is very nice. A very interesting aspect here is to find the best interface with standard Prolog code. Improve debugging verification environments. We had a talk on that in the previous session. I hope some people at least saw it. You know, that we find important, and the whole purpose of all this is to have a wider range of applications, but also, and very important for us, for example, is to make logic programming much easier to teach, because it gives you a better connection with logic theory, and it allows you, very interestingly, piecemeal delivery. So to extend the language in different directions piecemeal without putting everything together, because it becomes very complicated. So you add this extension, you add this other extension, and you have students play with the different sub-languages within a common manageable system. No, things that need addressing are, for example, better compatibility across systems. This has been addressed to some extent. It doesn't mean to have only one system, because you know, a lot of the systems make sense. It's not necessarily integration. We have, and the point I'm trying to make here is to accept that there can be several sweet spots in the design. All right, so that is on the first question. And the second question, integrating ideas from LP with other paradigms. Well, this is definitely something that we believe in. I mean, we've always aim to design a multi-paradigm language, connecting a little bit with what Mark was saying, in the direction of feeding things into LP from other paradigms, functions, an optional functional syntax, higher order, objects, agents, computational mobility, and so on, and even imperative features if people want. I mean, at least the control constructs, maybe mutable data structures. Now, interfaces with other paradigms. I mean, this is making systems talk. Of course, there's semi-automatic interfaces with languages, libraries, DBs, C, Java, JavaScript, Python, etc. Now, interesting things are new in this area, are new platforms, for example, compilation to JavaScript, WebAssembly. These are interesting, really interesting things that are happening. And there are, of course, many new opportunities, and we've had plenty of talks in this conference, about connections with machine learning system, explainable AI, and so on, so in improving that. And then in the other direction, so there's, we got into LP interfaces and now application of LP technology to other paradigms. I want to mention definitely the many applications and techniques for Datalog. Many aspects of CLP have moved to other paradigms. One important one that I think has been very successful is the application of logic programming techniques to analysis and verification of other paradigms. This was mentioned in the other panel also. This is normally done by translation to horn clauses. So the idea is to translate another language into horn clauses using this small step semantics, pioneered by John Gallagher and so on. And big step semantics also. That's mostly what we do in Chow. And this has been applied from things from pointer analysis to energy consumption for a whole spectrum of things, of executables or gas in blockchains. So it's been a very successful technique of applying LP technology to other paradigms. The Chow assertions models, which we talked about a little bit before, and in the previous session, which is a way of combining the best of the worlds of dynamic and static languages. It has also been used afterwards in approaches like hybrid and gradual typing, secure, etc. Now, with many of these things, and this is my concluding remark, it's a fact of life that many logic programming ideas have been adopted or even rediscovered in other paradigms, but the origin is not always great. I mean, Datalog, just speaking of Datalog, people mention Datalog, but they reinvent all the evaluation techniques. They invent I don't know how many things. Also analysis with tabling. Many things. Anyway, so that's it for my opening statement. Thank you very much again.
Okay, thank you. I will now try to maybe share my screen again. Right. Okay, I hope that you can all see Teresa's slides now, and then Teresa, just go ahead.
Okay, well, as with Manuel and probably some others, I'm mostly focused on Prolog in this talk. And what I'd like to do is structure the talk around two opportunities that I see for logic programming that I think have come up in the last, year, 2 years. So next slide, I guess, please. So one is, I'm mostly focused on integration in this talk with other paradigms. And one opportunity comes from the fact that Python has replaced Java in some programming rankings of both main implementations of Prolog and main implementation of Python is written in C. That makes interconnectivity very easy. And also Python, because of the dynamic typing, the lack of fixed typing, Prolog and Python data structures are very similar. Prologs are better, but they are similar. And what that means is that we can actually, that really opens up, I think, a lot of opportunities for Prolog. So for instance, there's a new XSP package that I've been working on for the last several months with some help from Michael Kiefer and David called XSP Pi. And it's okay, it's an interface, that sounds boring, but it is a very, very tight interface. So Prolog and Python are in the same process. A call and return to Python takes about 1 microsecond. So you can do 1 million calls and returns in 1 second. It takes about about 30 nanoseconds, maybe a little bit less on my machine, to per list element to transfer a list to between the two. I've tried that on lists of 100 million elements. So we've this interface was partially funded by BBN Technologies, and really within about after it got ready, within about a month or 6 weeks after it was created, we had interfaces for a particular project to Elasticsearch, Spacey, Face for embeddings, and a whole bunch of other things. And often you don't have to even write anything. You can just call a library directly. Sometimes you have to set up maybe just a little bit of Python code, but it's it actually has very good behavior. So this is just XSP calling Python. The next step is to have within the same process both the callback and to allow Python to call XSP. And that raises kind of the direction of maybe a Scala approach, at least not really too much like Scala, but inspired by Scala. Scala combines a functional language and Java, and you can kind of program in both willy-nilly. So again, that might be a good direction or it's one direction that I'm exploring. And what I can say is that at least in one project, it really came up, the addition of this was sort of a game changer. It went from people kind of discussing, well, what should we do in Prolog? Should we give up Prolog? To being very enthusiastic about it. Now, it's a research company, so it's not the way it would be in a lot of commercial companies, but the initial results are pretty good. So I think that maybe focusing on 1 or 2 really good integrations and using from Python or some other language, using all of their remarkable variety of libraries is a very good option. So next slide, please. The other opportunity that I've been seeing lately is that a lot of data nowadays identifies as non-binary. So basically, there's a lot of data that comes from machine learning. It doesn't have a true or false truth value. It tends to have some quantitative truth value. And in fact, this isn't just, this is getting more and more prevalent, I think, in industry and also in the AI community as a whole. I've heard intelligent people who consider a knowledge base really to be a large XLNet or BART or GPT-3 model. That's what they think of when they think of knowledge bases. I don't agree with it, but that's what I've heard. So I think an important question is, how can logic programming combine both probabilistic information from embedding spaces, from say one of these large language models that has kind of soft probability, soft max outputs. How do we combine those in a reasonable way? Because I think that by allowing logic rules to coordinate between these different subsystems, I think that might be a very nice area for logic programming. And in particular, I do think it raises some issues of what's the best way to weigh it if you're trying to combine probabilistic reasoning with some sort of strength value from a embedding space. And I'd also argue that the idea of declarativity is starting to fall apart a little bit in this, in the sense that you can come up with a nice set of rules to combine things, but quite often if you're combining different pieces of evidence from different machine learning techniques, you have to assign some sort of confidence to your rule. So the idea of just simply writing rules, I think, is in this new world of machine learning data, that's kind of becoming obsolete. And I think that certainly XSB has to do a better job at integrating some of the great work that's been done on learning values, quantitative values for rules, with Prism and CP-Lint and PSL and a whole bunch of other things. So really combining, being able to write a rule set and then learn the actual quantitative values, I think that seems to be more and more of something that logic programming in commercial research needs to be done. Now, I kind of want to end up on saying that compared to machine learning techniques, logic programming does have a huge advantage in that it doesn't require training data. You can actually write, as Mark said, you can write declarative rules, and that's why I think why we're all here is that we think that's very nice. But we also, I think, want to be able to exploit the results of machine learning and the results of all of the investment that's going into training data really across the world. And hopefully this would be a good way to do it. So that's my talk.
Okay, thank you very much. And then we have Jan.
Yes, I think I'm unmuted now. So thanks for the invitation, and I'm glad to see a lot of different perspectives into this problem. Quite more different perspectives than I'd expected, actually. I started SDY Prolog long time ago. In those days, I mostly saw it as Prolog as being the declarative language and communicating, connecting to the rest of the world. So that is how SDY Prolog evolved for a long time as a reasoning engine, intended as a reasoning engine, as a rule-based engine, and talking to various originally to graphics, later to RDF, to the network and those kind of things. That was more or less the intent. Since a little bit over a year, I'm now no longer academic, but I'm running SDY Prolog as a company. And I come to the conclusion that some things have changed in this respect, in the sense that getting away with Prolog as a declarative language, a rule language, is no longer working. So we have to go into more proper logic for doing the reasoning. And the role of Prolog is changing a little bit to helping connecting the reasoning component to the external world. That's sometimes embedded. So at the moment I'm working with the work that has been started in Dallas and is now continued in Madrid about CASP, and including that embedding that in Prolog in a sensible way, and make that talk to the external world that my client wishes. I've done something similar in robotics projects where I use Prolog to make the communication between in this case, domain-specific logic-based component and the robotics world. So that's the world that I'm living in. It's very much a bottom-up, incremental approach to find practical solutions to how to deal with Prolog as a language in real-life applications. Coming back to this panel, I see there are kind of two things we can. You can see, let's say, the first statement is how do we deal with all these logics, and then you can think about kind of rebuilding a Gondwana where everything lives together, and that's something I can't really contribute in, because it looks very, very appealing, but I think it's far too complicated for me. I've seen some work being done. I've done some work with Teresa and David on getting a lot of the XFB stuff to SWI Prolog. And there I see that getting all these techniques, all these various tabling techniques, and eventually also constraint techniques into one system is really complicated. And I think we are kind of reaching, as far as I see it, reaching the limits in how far we can get in this kind of integration. So I'm more interested in let's say, considering Prolog as a role-based language that where you can do a little bit of logic, and you can also do procedural things, and use that to connect pure logical components to the outside world. That's more or less the main focus that I'm concentrating on, and that should be a little bit more clear in the second slide. Joost, yes, thank you. So I see it that we have in the middle, we have this thing that actually we have pure declarative programs. That's the things that are in the bottom left. So it can be ASP, but it can be all kind of other pure declarative systems. But these things can't talk to the world themselves. So we need something to if we have problems from the world, to assemble the programs that we really need to solve. Then we solve them, we get some output of it, and then we have to feed that back to the world in some way. So the question is, what language can you use for doing that? And I think there, Prolog is really an excellent language to do that, because it's so natural to represent these kind of programs in Prolog. It's so easy to represent horn clauses and all these kind of related programs in Prolog. And I think in that sense, it's a much more suitable language than what's now used quite commonly, Python, for doing these kind of translations, or Lua, or whatever you want to use for that. And that, in that sense, I would like to connect to Teresa to see how she sees the role of Python and versus Prolog, but that can be later in the discussion. That was my part of the introduction.
Okay, thank you. And then finally, we have Francesco, who I think will be sharing his own screen.
Okay, thank you. Can you hear me?
Yes.
So let me try to. Can you see my presentation?
Yes.
Okay, so I will try to be also a little bit provocative today. Okay, so I start from the title of the panel, asking whether logic are islands, and at some point I think I will provide what I believe is the perfect perspective of those who are outside our community, and you will know why I think for those guys maybe logics are like icebergs. Okay, so let's start from the foundation. So we have different languages, logic-based formalisms, Prolog, ISP, FOID, and many others. Each one, if you look, after so many years, has strong foundations, strong theoretical foundations. They were born from different starting points and communities. They had different goals in mind, maybe, and nowadays we have for those good tools and also some good applications. So let's go to the first question. How can different logic formalisms combine, and does it make sense? So I think it makes sense. Why? Because they have different strengths. Okay, so think about different ways of evaluating logic programs. Sometimes top-down is good. Sometimes it's much better to go bottom-up. What about numerical domains if you want to see constraint programming as part of this family? And they all also have good implementation. Why not combining? Because of course there is a gain in this, and there are examples already in the literature. So we have combination of ASP and CP, CP and Prolog, ASP and ontologies, ASP with the different theories, and I think it makes sense to continue to continue because there is some gain here, right? We can combine the advantages of all of them. So for the first question, I said clear yes in my view. Let's go now to go a little bit up to something that is, let's say, not known but partially known, that there is no silver bullet, okay? And this is connected also to the fact that different formalisms have different strengths. And I think this is a famous anti-pattern, you know, in software engineering, saying that you don't have to fix with just one tool and apply it everywhere to kill whatever, okay? So I think this silver bullet problem is very common in our community. Maybe you don't agree, but I think it's so, huh? And we can maybe discuss about that. But it is also well known, especially to practitioners, to all of us that tried to implement any real-world application. We immediately crashed against this, that logic tools alone are not enough. And so we can go to question number 2. We were forced to actually combine and integrate with other programming paradigms, databases, semantic web, C++ or Java or whatever. So the second question, whether it makes sense, and of course it's clear, it's a definite yes as answer also from me. In the one hand, makes me happy. Makes me happy because it reminds me my first publication on an interface, a Java interface for DLV, to connect the logic world with Java at the time, in 2003. I continued also proposing hybrid languages in which you can mix in a single file ASP together with Java, and this work is continuing with external interfaces for our last software. But please check what other colleagues did. There is a very nice interface for Klingo. We heard 1 second ago by Manuel. There are plenty of works of combinations of Prolog with other languages. There are programming tools. So of course it makes sense to continue with that. Sorry, I will skip on this. So, but this question makes me also in a sense sad, because I look at other formalisms and I see that logics in general are not so famous around, okay? So it's like any form of logic programming, it's like a forgotten beauty. If you look from the perspective of AI, we are GoFi, right? Good old-fashioned artificial intelligence, huh? And we lost a little bit of, there is a distance with what is considered today AI in general. And from the programming perspective, in a sense, we are obscured by imperative and functional environments. Teresa mentioned the Scala and other, and Java and so on and so forth. So if we look from outside, all this thing that we are discussing is below. It's not seen, okay? What is visible? Well, if you ask somebody outside the community, they say, logic programming is a beautiful, formal, 5th generation computing system stuff, right? But this is not the case. We developed quite a lot. There are so many nice tools, maybe integrated. So my provocative questions now is how to discover more. For sure, we have to continue hybridize our technology with other programming languages. We have to provide books and whatever. And I leave you with this question also. How can we make all this nice world that we have, that is invisible to the others, more visible? So thanks for your attention.
Okay, thank you. And thank you very much to the other panelists as well for these very nice and thoughtful position statements. They were very interesting. They gave a broad view, I think, of the issues. They also took perhaps slightly more time than I originally anticipated. So maybe it's a good idea to give now the opportunity to the audience to maybe ask some questions or make some comments. So perhaps you can raise your hand or type a question in the chat if you have something that you would like to ask. Okay, Benjamin.
First of all, great panel topic. I wanted to make a couple points and get the panel's feedback about directions or thoughts on it. I just want to say, I think in terms of progress in the field of LP, I do think a crucial one has been that transformations are a very useful way to build systems. So most people outside of KRR community and the logic programming community, I'll just call it LP, don't really understand how the systems are built, where there's a stack of transformations. In the work by myself and collaborators over the years, we've been able to get lots and lots of different expressive features integrated well from a whole bunch of different systems into common systems by using that as a technical approach in development. So you transform defaults into negation as failure. You transform higher order syntax into first order syntax and various other kinds of transformations. So I think that to me, an interesting direction for how best to do integration of paradigms is often to have a lot of flexibility in the tools for doing the transformations themselves, and to have the systems consciously architected to use those as modules as you go along. So I'm curious if other people agree with that as an approach. Another point, which I think tends to be dismissed, is the sheer importance of the high-log type higher order syntactic flexibility, in particular when bridging to other programming paradigms, which typically take as a matter of course that you can do various kinds of higher order meta syntactic expressions or compositions in those languages. And for example, it really revolutionized tools for diffusibility in well-founded logic programming. Finally, it seems to me that a tough issue in foundations is that so far we have not studied terribly well the even the formalization of distributing inferencing, including even with a homogeneous KR, but especially as you go to heterogeneous systems or knowledge representations at various different grains of concurrency, as well as of distance of heterogeneity of the systems. So I'd love to hear people's comments on any or all of these dimensions.
Thank you. Does any of the panelists want to respond to any of those questions?
Well, I can comment a little bit on the transformation question. So one thing that I was kicking myself about when I finished my slides is that there are one kind of, we talk about Prolog and ASP, and one aspect or one language that's sort of in between is Flora and Ergo, which actually does give maybe certainly a bit more of a logical point of view than XSP Prolog. So I guess, and in fact, that's built on top of XSP, essentially with a very sophisticated compiler and set of transformations that Michael Kiefer did. So I think that's also, it's just worthwhile mentioning that as maybe a third way that's closer to Prolog.
Thank you. Any other reactions to?
I can add that I totally agree with Teresa on the importance and Benjamin on the importance of transformations. I mean, a lot of the things that we do to support other languages, support other programming styles, other paradigms, and so on are transformation based. It's great, and this, desugaring and so on. And higher order is also very important. Now for us, higher order has to come with the ability to compile it away as much as possible. That's also that's also we work hard on. But sometimes very convenient. Yeah.
So, please.
Okay.
Please, Mark.
Well, on the same point, higher order logic. We of course know that higher order cannot be translated in general to first order. And so it's a nice example to illustrate, let's say, theoretical questions and unsolved theoretical questions. We know for sure that not all higher order can be translated in first order logic or in logic programming. So the question is then, we need to have a good understanding of the underlying knowledge and how to integrate this with the kind of languages we use, just to be able to study when it can be transformed and when it cannot be transformed. And I didn't hear the other panelists talk about this, but I think that's the kind of direction I want to go. I want to understand, first of all, I want to have a logic where higher order is integrated and in which we can then study how to transform away higher order logic. Okay.
Francisco, you also wanted to?
Yeah, I want also to comment on this thing of using logic, maybe that I got at some point, of using logic as for solving tasks that are good for logics, and use this as with interfaces. Okay, all this thing I think is rather available. I still stress what I said also in my talk, that is not visible outside. So maybe we should also converge in this sense to a common way of connecting imperative languages that are much more used than ours to our stuff, so that people can use it and enjoy it. Otherwise, we will be detached from the rest of the world. This is what I want to add with respect to this.
Okay.
Just, I think Annie had a question. Maybe you don't see her.
Yes, I do. There were also a couple of questions in the chat, but go ahead, Annie.
Oh, okay. Actually, I have a quick question. I started actually I had a question about external integration, but as I hear all your interesting positions, and it's really great different ideas. Actually, I have a very specific internal integration question, right? The people using Prolog, and that's missing sort of constraints. So they're CLP, constraint logic programming. And of course, more recent years, people know there are more people studying answer set programming. There you have constraints. Okay, so right, so the integration, is about the CLP and the ASP, right? So Prolog people need a constraint, but what about the ASP people? They do not feel they need, so well-founded semantics, or, just at some point, they suddenly give me empty model, no information. So how do they live with that?
So I will say something. So since quite a long time, DLV as an option to compute the well-founded model. So I think, and I think this can be easily implemented also with other ASP systems. So sometimes it's a matter of sharing knowledge about what the system do. And I think it definitely makes sense if you have many tools to use the right tool for the right problem, and not just to stick with my tool is the best and I use it with whatever. Okay.
So that's why you don't miss Prolog.
Well,
I see. I didn't know. Great.
It's just a matter of what you solve. Okay. Maybe we were just concentrating on some NP or beyond NP problem where you, with guess and check, you capture it so nicely. But sometimes if you have to do query answering, it depends on what you have to query, and maybe you are just doing well-founded, even if this is not declared. So it really also depends on the problem that you are approaching.
Thank you.
Maybe I can say a word how it is in the IDP system. There is a twist that we consider explicit definitions with undefined predicates. And our experience is that if you take that as so that fits the view that very often our definitional knowledge defines certain concepts in terms of other concepts without providing the definitions for those other concepts. Okay. Now, if you take that kind of view, then we simply observe that well-founded and stable semantics for that type of definitions almost always coincides. Okay, so the two coincide. There's no difference anymore. The gap between well-founded and stable semantics, when does it arise? It arises when there are these dependencies over negation, which are created to make the search space split. But in our language, that disappears. The search space is split because certain predicates are not defined anymore, and therefore they can be chosen in arbitrary ways, subject to certain constraints, but not because loops over negation in a definition. And therefore, well-founded semantics and stable semantics coincide in such a context.
Yes, I would like to say something about that. So I'm now working with the CCASP system that started in live in Madrid and well before that in Texas. And I'm now integrated in a way that you can have, let's say, pure Prolog roles that you can query both using XSP tabling, so using basically well-founded semantics. You can query the same data set using CCASP, so you get the ASP semantics, and of course you can just run it as a Prolog program and see what happens. But what it turns out is that depending on the problem that you have, depending on the language that you have, you will write down the system in a different way. So these best practices that tell you how to write down your knowledge depending on the language. So it's not that easy to actually reuse the same set of rules using different semantics. Because that, I think it's a little bit of an answer to Frans, or at least there's a reaction on Francisco's statement about applying well-founded semantics after ASP does not give a model. It's not always that simple, I think.
Okay, thank you. I think we are almost out of time, but there was a very interesting question in the chat where Walter asked, can an integration of language paradigms be kept elegant? That is, can you avoid a mess? So maybe just to wrap up the panel, I want to see whether any of the panelists has like a very short suggestion for keeping things elegant when you integrate these paradigms and how to avoid a mess, as Walter put it.
Well, I'll plug the XSP Python interface, which basically what you get back from Python is a big XSP term, maybe a list of XSP terms. So from our perspective, Python is a term server. I'm sure Python programmers wouldn't appreciate that, but that's our perspective. But I also have to say that sometimes there's a saying, to make an omelet, you have to break eggs. And I think sometimes the connectivity and the ability to do things is more, even if you have to, I'll probably, the logic police will probably come and take me for this, but sometimes you have to actually be a little messy and get something done and then go back and try to clean it up. I hate to say that, but for practical purposes, sometimes you got to do that.
So very, very quickly, I mean, on the combining, if it's a mess or not, which is a very valid question. First, we try not to make it a mess because we're pretty much very much into combining. I think it's a lot less of a mess combining into Prolog than the other way around, because Prolog can, understands the backtrack and the other way around is very complicated. And then on the laziness, there's a question on the laziness when you combine functional programming in the Chow combination. Laziness is supported and is supported through delays, because delay declarations are very similar to laziness, so you can easily do it that way.
Okay, there's also a lot of interesting stuff being said in the chat, but I think that this is probably all that we have time for, so that we can still have a short break before the invited talk. So I would just like to thank the audience for the questions, and of course like to thank all of the panelists again for their very interesting contributions here. So thank you very much.